Looking at our 12 basic functions, we're going to go a little bit more in depth with a couple of these in this unit. To start off with, we're going to go further in depth with linear and quadratics. Now, the nice thing is we kind of already know what some things are. Like, for instance, the zero function. It's in the form of f of x equals 0. The constant function. This is where we have f of x equals a, or some number. Okay, so like when we were doing piecewise function, the constant was going to be our horizontal line. Our next one is obviously going to be a linear function, which is in the form of f of x equals mx plus b. You could also think of this as ax plus b if you really wanted to, but this is just the slope. This is just an equation of a line. It's a linear. Quadratic. Quadratic is in the form of, in standard form, ax squared plus bx plus c. So with all of this being said, the degree of this, or the exponent of this, for a constant is going to be 0. For a linear, it's 1. Quadratic, it's 2. So this is the degree. For a zero function, it's undefined. Just an FYI. So these are all things that we've talked about before. We're just going to go a little bit further in depth with them, specifically the linear and quadratic. So with that being said, sometimes we'll be asked to find an equation of a line in a different format than what we've seen before. So for instance, you might be given something that looks like this, and you're supposed to find the equation of that line. Now, remember that function notation is pretty similar to a y equals. So we need to find our slope. And slope, remember, or you can think of slope as the rate of change as f of b minus f of a divided by b minus a, where b and a are just points. Okay, so with that being said, we have, I'm going to pick the right one to be my f of b. So I have f of 3 minus f of 1 over 3 minus 1, in this case to find my m. Well, f of 3 is 7, f of 1 is 3, so that's going to be 3 minus 1. I'm going to reduce this. I get 4 over 2, which gives me my slope. Now, I am supposed to write that equation in y equals mx plus b. Well, I have the m. We know it's 2. I have an x and I have a y technically. You can either choose to go with that first coordinate, or you can go with the second coordinate. I'm just going to go with the first one. So my x in that case is 1, and my y is 3. And then I'm going to plug in this information in order to find my b value. So if I'm looking at this, I have 3 equals 2 plus b, b therefore equals 1. My linear line, or function I should say, is f of x equals 2x plus 1. So even though the notation from the beginning looked different, it's still the same thing that you guys have done in algebra, where you're trying to find the equation of a line given 2 points. It's just in function notation, just a little bit different. The rate of change, the average rate of change, speaking of which, going back up here, this equation right here, we have always denoted it with lines. When we are using a rate of change, or average rate of change, this can technically be used for any type of curve. So if I have a parabola, I could use the average rate of change. If I were to have the absolute value of x, I could still use that average rate of change. It's still the same formula, same concept. Sometimes it just looks a little bit differently. When we're talking about quadratics, we know that there are two different types of equations for quadratics. There's what we know as standard form, which is the ax squared plus bx plus c. And then we have vertex form. And you guys have seen these before, just different ways of looking at it. Vertex form is f of x equals a times x minus h squared plus k. So with standard form, the a, the b, and the c are related to the graph, but if you have a picture of a graph, you cannot necessarily, or if you just have that equation, you cannot necessarily just pick out and say what certain information is. It is useful because it is in standard form, but if we're looking for where does the bottom of the parabola occur, or where does the maximum of the parabola occur, the vertex form is actually more beneficial. In the sense that the vertex is located at h comma k. Now, notice x and h are related inside of parentheses, and like we've talked about before with transformations, that h comes out opposite of what we see, so it's actually a positive h, and then that k is our shift. So like our transformations, the h tells us how far left or right, the k tells us our up and down. Now from prior experience, we know that the a represents a stretch, but the a also determines the direction. If it's a positive a, our parabola will be up. If it's a negative a, our parabola will be down. And that, think about it, is in terms of the reflection over the x-axis, which we've talked about with transformations. So from this information, you guys will be asked to use it in order to solve or determine the vertex, the axis of symmetry, and that kind of information. So for instance, if I were to have f of x equals 2x minus 1 squared plus 6. Well, from this information, the vertex is located at 1, 6. It is going to open up. We are also going to have the axis of symmetry, which means just the reflection line. Where does the parabola, if I split it in half, where does it fold over? The axis of symmetry occurs at the x value for our vertex. This is information that can be found using that vertex form. If you're using standard form, you're going to have to convert it into vertex form, where we are completing the square, which we've talked about before. You could also do some factoring. There's multiple ways that you could go about it, but for right now, let's just work on just the generalization of standard form versus vertex form, and also looking at that average rate of change.